graphing a quadratic function, we're going to do this by completing the square. And we're going to complete the square to get this form. As you see, we have our quadratic function, y equals negative 3x squared minus 2x plus 1. We're going to use completing the square to get this quadratic in standard form. And standard form of a quadratic is y equals a x minus h all squared plus k. That is the standard form of a quadratic function. And how this helps me that h and k is my vertex. And that lets me know that, remember, the vertex for a quadratic is the lowest or highest point of the parabola, because when you graph a quadratic, you get a parabola. The a will let us know a little bit about whether it's open up or open down, and the kind of the thinness, how wide the quadratic is, or if it's thinner. So first of all, let's see if we can get our quadratic in this form, and we're going to do it by completing the square. Well, to complete the square, I need my x squared to not have a negative 3. We want that to be a 1, that coefficient for x squared to be a 1. So what I'm going to do, I'm going to factor out a negative 3. So when I factor a negative 3 out of x squared, basically you're dividing by negative 3. So 3x squared divided by negative 3 is just x squared. And then you do the same thing with the 2x. Think of it as dividing by negative 3. When we factored that 3 out, I'm left with x squared. And then when I factor the negative 3 out of negative 2x, again, it's the same as dividing by a negative 3. I end up with there's two negatives, or that minus and a negative is going to give me a positive 2/3, and we'll get back to that here in just a moment. And I still have my plus 1. So let's just simplify this and make it look a little better. So I have x squared plus 2/3 x plus 1. Now, the completing the square part, you take the coefficient of your x term, which is 2/3. We need to take half of that and square it. And then we add it to this part of our function that we're working with. And that can be really confusing. So I understand how completing the square is not the funnest thing for some. Okay, so if I take half of 2/3, so let's think about that. If I take half of 2/3, and then we're going to square it. So half of 2/3, well, that cancels, so I get 1/3, and 1/3 squared, that is what, 1/9. So that's what we're going to add to this part of our function, plus 1/9 plus 1. Now, the whole purpose of completing the square is to get this to where to factor. Okay? And if you remember right, this is actually going to be, this is a perfect square. 1/3 times 1/3 is 1/9. And then if you add, so 1/3 times 1/3 is 1/9. And then if I add the 2, I get 2/3. So this is a perfect square trinomial, and these can be factored quite simply. So that's the whole purpose of completing the square, is to get that perfect square trinomial. So we can factor it. Oh, one thing I almost forgot. Let's go back a minute. Almost left off a part. So let's go back, and when I add, I'm going to change colors here. So when I added that 1/9, okay, I also have to subtract it, because I can't just arbitrarily add a number without adding it to the other side. which you could do plus 1/9. You also have to remember this -3 is out there. So technically that would be a -3/9, or a 1/3, if you want to look at it that way this time. Because we have to remember we factored that -3 out to start with, so we can't forget that also. That goes with that 1/9. So what we're going to do, we're going to subtract it right here, because remember we just added it here, the -3. Remember that's a distribution property there, the distributive property. So technically we're adding a -3/9, which is -1/3. Okay. So we're going to do the same thing. We have to make sure we do the opposite on the outside, so those two end up being 0. And that's a lot of times where it gets confusing, because we keep adding and subtracting these numbers in there. So again, that's a -3/9. So that means I need a +3/9 on the outside. Okay, since that's a negative, if that would have remained a positive, then I would have subtracted 3/9. Okay, so what's my next step here? Let's get back. So that's going to give me, again, -3, and then that perfect square trinomial factors into x plus 1/3, because x times x is x squared. 1/3 times 1/3 is 1/9, and then 1/3 plus 1/3 is 2/3. So that's perfect square trinomial squared. Plus, and then 1 plus 3/9. What would that end up being? And that ends up being 4/3. So when we add these two together, we end up getting 4/3. So there is our quadratic in standard form. As you can see, it's in that same form where a is -3, h would be -1/3, and k would be 4/3. So that gives us our vertex. Okay, I have -1/3 and 4/3. So I could graph, or we could plot those points, or that point, excuse me, just one point, that's our vertex, by definition of it being in standard form. So let's look at this on a graph. Okay, so let's just draw. I'll try to be as straight as I can. Okay. And if we think of -1/3, so remember what our vertex was -1/3 and 4/3. So -1/3 would be about 1/3 to the left of the center. And then 4/3 would be, let me get my parenthesis there. 4/3 is what, 1 1/3. So I go about 1/3 to the left, and then up 1 1/3, and there would be my vertex. We're graphing the whole function, so let me go ahead and write it here, just so we have it to look at. Plus 1/3 squared plus 4/3. Now what would my y-intercept be? Remember, your y-intercepts were x equals 0. So if I put 0 in for x, if we figure out what that would be, see, if I put 0 in there, then that would give me negative, so that becomes 0. So I'd have 1/3 squared, which would be 1/9. -3 times 1/9 would be -1/3, so I get 3/3, which is 0/1. Okay, now I know I did that a little quickly, but if you put 0 in for x and calculate that, you'll get 1 for your y-intercept. So let's plot that point. Okay, so, and we know it's open down. Well, how do I know it's open down? Well, that's because the a is a negative number. So if that's a negative, that tells us it's open down. If it was positive, it'd be open up. So we have our point, so we know that it is going down. We could also find our x-intercepts. Okay, which we might do that, or that might be a different problem here. And then knowing it's symmetric, that means I know that if this is 0, 1, Then I also know it's going to have another point that's going to be 1/3 away. And so there's a rough sketch of what our parabola would look like. And I said we could find the x, so let's go ahead and find the x-intercepts. It kind of looks, you know, my graph is a little rough, so it would help, since we're already here. Let's see if we can find out what the x-intercepts are, because I think my graph is off a little bit to the right here. So finding the x-intercept, so what would that look like? Okay, so let's go back to our original function. So we can get a more accurate sketch. Let's see if it's factorable. Now, if it's been a while since you've factored, this might be a little difficult, but I'm going to factor this one by reverse foiling. There's several different methods to factoring. Okay, because negative 3x times x would give me 3x squared. Then I need to think about how can I get a positive 1. I can do a plus and a plus. There's only a 1 and a 1. That's the only way I can get a positive 1. And then I need to see, does this combination give me my negative 2 in the middle? And if you think about, that's negative 3x plus 1x, which is negative 2x. So yes, it does. So what are my factors are going to be negative 3x plus 1 times x plus 1. Set that equal to 0, which is what we do. Whenever you're finding the x-intercepts, you always let your y equal 0. And that tells you what your x-intercepts are. So I have negative 3x plus 1, and then 0 equals x plus 1. So it looks like my x-intercepts are, oops, correct that there. That should be negative 1. Negative 1, because we subtract 1 to get it on the other side. And then here, I'm going to move my negative 3x to the left side, so that'll make it a positive. So it looks like x equals 1/3. So there are my two x-intercepts, which if we go back to our graph, okay, this one was pretty close. This one was off, so that should have come down just a little more narrow, because that should be at 1/3. Okay, so again, as you can see, this is a rough sketch of a quadratic function using completing the square.